First things first. Key thing is underline the keywords. Sphere, volume, sphere, terms of pi. Go to page 9 or 10 of your maths tables that you'll be bringing in with you for your Christmas exams, because you all own maths tables, right? Yes. Now, please don't do one of the worst mistakes ever. You look at the circle and you look at the sphere and you can't tell the difference between the two of them and you use the wrong formula. When you're looking at the circle or the sphere, please make sure it says sphere or circle beside the circle you're actually looking at. You laugh now, but it happens all the time. Okay? So, please, next thing you have is V and A. Use the V formula because you're using volume. I know this sounds really, really patronizing, but you surprised how often that happens. Now, what's the radius of the sphere? 3. Lob that into the calculator. What you get, Daniel? 36 pi centimeters cubed. Right. Easy money so far. Now, the sphere is now removed. What happens when you remove the sphere? The water level? It drops, doesn't it? It was at the very top. The water was at the very top in the first picture, and it's not at the very top in the second picture. Now, what happens here is you lost a volume, didn't you? The volume you lost is in the air is actually in the shape of a cylinder. Would you take that? That the volume of the air at the top is in the shape of a cylinder. This volume of air is actually equal to the volume of the sphere. Because when you took the volume of the sphere out, the volume of water, the volume removed is the same as the volume of air that now fills it. Okay? So what we're going to say is volume of air is pi r squared h. Why did I use pi r squared h? It's in the shape of a cylinder. What's the area of the sphere? Yeah. Do we know the radius of the cylinder? Yeah. What is it? 5. Right. So pi times 5 squared times h equals 36 pi. Cancel the pi's on both sides. And then h is equal to 36 divided by 25, which is... Write that out, can we? Yeah, just something decimally. 1.44. Who got that out of interest? Well done. Marking scheme assist or on your Todd? Yeah. Alright, guys. Next thing. Everybody good so far? Okay. Next thing. A cylinder has a height of 18 centimeters. Oh, sorry, the cylinder has a height of 18 centimeters. The curved surface area of the cylinder is cut from a rectangular piece of metal measuring 35 by 20. Find out how much metal will be left over when the curved surface area of the cylinder is cut out. Alright, go back to your cylinder for a second. When we unravel a cylinder, what does it look like? Actually looks like 2 circles and a rectangle usually. Unless it's an open cylinder, in which case there'll only be a circle on the bottom. Now, what I would have taught you guys earlier in the year is, what can you say? This is known as the curved surface area. Do you know that? Do you know the side of a Coke can where it'd say Coca-Cola? Yeah. You can cut that out into a rectangle and unfold it. So what's the formula for this rectangle? So when you go to the cylinder, you'll see two formulas. You'll see V equals pi r squared h, and you'll see A equals 2 pi r h. Which one do you choose? Because that's the area of this part here. If I wanted the total surface area, what would you pick? You'd have to add You'd have to add on another 2 pi r squared. Why? Circle on the top and circle on the bottom. You'd have to add on another 2 pi r squared to get the TSA, or total surface area. But however, in your log tables, all what you have is curved surface area, which is CSA. Alright, that's what's in your tables. Now, the CSA is 2 pi r h from the previous question. And what is r in that question? 5. And what's the height? 18. That gives it to us there, doesn't it? Yep. And what's all that? 180 pi, is it? Yep. 180 pi. Now, what's the area of the full thing? The full rectangle. 35 by 20, which is? Yep. Area of rectangle is 35 by 20, which is 700. And then get your 700 and take away your 180 pi. What you get then? 134.5 centimeters squared. Only volume is cubed. Alright? Cool. Alright. Let's see what we can redact out. Blah 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 blah. Daylight savings time. This would mean the clocks would not go forward 1 hour in March and not go back 1 hour. A transition class carried out a survey. That's all I need to know. Would you agree? That's all you really want to know. The class surveyed a random sample of 800 people in the local area. Find out the margin of error. Give your answer as a percentage, not a decimal. Alright lads, we did this a couple of days ago. What's the formula for margin of error? Yeah, and 1 over square root of 800, which is? Now, the problem is, this is in decimals. I need to multiply by 100 to change into percentage. And what we're going to get is 3.54%. Is everybody okay with 3.54%? What? No, you have to write it. You can just do equals, Daniel. It's no big deal. You're only rounding it off. So that's what you would have got. And then you change that into 3.54%. Now, in a survey, 350 people supported the proposal to abolish the daylight savings time. So 350 divided by how many people? 800. And what's that in percentage? So once again, you'd end up with 0.4375, which we all know is 43.75%. Is that okay? Now it's probably going to ask me for the 95% confidence interval. Does that make sense? So what you do here? 43.75 take away 3.54. Okay, you get 40.21%, less than P, less than, and now you have to add them on. So 43.75 plus 3.44, 47.29. Who got that one like completely out, nailed it? Like, sure. Why do you have to write down the second part? Okay, I'll highlight the part that tells me it. Use your answer in part B, part 1 to create a 95% confidence interval for the percentage population support the EU proposal. Anytime you see that keyword, 95% confidence interval, you know you're doing that trick. Is that right, Peter? Did you get it out? A local newspaper report that 50% of people in the area support EU proposal. Use your answer in B part 2 to above to conduct a hypothesis test at the 5% level of significance to test the newspaper's claim. Clearly state your conclusion in the context of the question and give a reason for your results. We didn't actually do this part actually, so this is why we're doing it now. So, just give me a second with it. Drawing a small ears out anyway, right? So, what you do is this. H0 is what's called the null hypothesis. And the null hypothesis is always nothing has changed. So the null hypothesis is 50% of people support the EU proposal. Is that okay? So this is what's called hypothesis testing. You're testing the hypothesis. Now what's H1? H1 is always the opposite of H0. So how do I write H1? Yeah. It's best to say do not support. Just do the opposite. Do not support what's it called, the EU proposal. Okay. Now, what's your conclusion? You reject which one? Reject H0. And why do you reject H0? Because it is not in between 40.21% and 47.29%. Because 50% is not within 95% confidence interval. Okay, I'll do more of them later on, and I'll send you a link. Now, you have the rainfall between what's Valencia in June and total sunshine hours at Valencia, County Kerry. Is there Valencia, County Kerry? Jeez, I thought we were talking about somewhere like yeah, I thought it was Spain or something. Now, what's the range of the rainfall data, lads? The highest score minus the lowest score. So what do we get? Who's the highest? That one? 155 is the highest. And what's the smallest? 47. And then you took them away from him during 108. Peter, which year had the highest rainfall? 2003, was it? Which year had the least June sunshine? 2002. Okay. Based on the data on the table, write down the year with the best June weather and give a reason for your answer. Which one do you think is the best weather? 2006. 2006 had the lowest rainfall. Yeah. Lowest rainfall, highest sunshine. Now you can see what they're doing there is they're front loading marks there to make sure people pass. Okay, so they actually give you some nice marks there early on. Okay. So, and you write down 2006. Happy days, right? Now, part C is a medium level usually. Write the rainfall data in increasing order and hence find the median of the rainfall. Now, what to do exactly what he says here. So, what's it in order? Just call it out for me. 47. Yeah. 72. Yeah. 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 100 what? 101. Yeah. 133. Yeah. 134. Yeah. 129. Yeah. 155. All right. How many of them is there? 1, 2, 3, 4, 5, 6. That's 1, 3, 3. How many of them is there? 1, 2, 3, 4, 5, 6, 7, 10. 10 means the middle two. Who are the middle two? 94 and 101. Yeah, 94 and 101. And we need to get the average. So what's 94 plus 101 divided by 2? 97.5? Okay. You guys did the mean yourselves, didn't you? So lads, to do the mean, I'll quickly go back. You guys are just going to give me the answer. You add them all up and divide by 10, don't you? What you get for the mean? I might get 181. 181.8. Okay. Really good. Next thing. For what years was the sunshine data within 5% of the mean number of sunshine hours in Valencia? Okay, within 5% of the mean. You said the mean was 181.8. Take away 5% and add on 5%, but have a really lazy way of doing it. 181.8. If you want to take away 5%, just multiply it by 0.95. You're retaining 95%. And that is 172.71. The next one is I'm going to multiply it by 1.05 to add on 5%. And that will be 190.89. Now, what I want to know, lads, is within 5% means take away 5% and add on 5%. So Sam, this yellow number here is, sorry, the blue number is what happens when I add on 5%. Peter? And then this lower one is when I take away 5%. All right, how many years are in between there? What years are in between those two scores? 2003, anything else? Yeah. Is everybody happy enough with that? 30 years that are within those two scores. Was anybody able to calculate the standard deviation of the rainfall data using your calculator? Yes. What'd you get? 33.46. Everybody cool with that? Correct. One decimal place, 33.5. Alright. Does everybody know how to do that? Yeah. Calculator was? Yes. Alright. Awesome. Let's move on. What? What do you want me to do? See the that increases it by 5%. If I multiply by 1.5, I increase it by 50%. If I multiply by 1.09, I increase it by 9%. It wants me to increase it by 5%. Within 5% means 5% above or 5% below. Alright. Let's complete the scatter plot. So basically what it's doing is it's done the first 4 points, which is so I have to grab this here. It's going to be difficult. So I grab this here. Send to new page. No bother. Shrink it down. And I have to draw this onto my scatter plot. Okay? Scatter plot. Scatter plot. Alright. Ready? We've done 72 and 169. We did 133 and 124. We did 155, 180. We did 101 and 173. Now I have to go for 94 and 173. 94 is here. 173 was somewhere around there. So just a rough idea where it is. You're not going to be able to do it exactly. 47 and 240 roughly. 47 will be around here. Where's 240? All the way up there. That's a real outlier, isn't it? Or I don't know yet, actually. Next one is 150 and 160. 150, 160. 150 is there, 160 is there. Okay, that's that one done. 134 and 170. 134 would be about here, and 170 would be about here. Once again, you're just doing approximately. 94 and 228, so 94 and 230. 94 about here, and 230-ish around here. Next thing, 84 and 205. 84 around here, 205 around here. Okay, now, if I was doing a line of best fit, what do you reckon? Just out of interest. Oh, that's it. Bit on there. Something like that? Yeah. Yes. Now, what this is basically saying, lads, is the higher the rainfall, the lower the sunshine. That's why it's a negative skew. Or the higher the sunshine, the lower the rainfall. There is a negative correlation here. Which one is it? Can't be positive. Not that one. Not that one. Is there a correlation? There is, so it's not that one, so it must be minus 0.6. Is that right? Explanation. Alright. So, as sunshine rises, rainfall decreases. This is a negative correlation. Okay? There you go. Is that the question? Lads, you're going to have to do another hypothesis test on the next question. So you 5 and 6 tonight? Yes, sir. Thank you.